So let's begin looking at the blood vessels of the head and the neck. And I'm going to run through these with you in your handout. You should already have a number of things crossed out, your handouts. Is that right? Okay. So I've taken the page, this page that has the arteries. We're going to have both arteries and veins here, but obviously this is arteries of the head and the neck. And I've eliminated quite a few of these. Okay. So the biggies, and one that you've already studied is, of course, the common carotid. We had this when we studied the torso. And we know the right common carotid comes off the brachiocephalic, and the left common carotid was by itself, but we've studied those. Now, the common carotid should lead you to the fact that this is going to divide, right? And so the other two main arteries we're going to have here then are the external and the internal carotid arteries. These are the ones that you want to pick out in the diagram initially. The picture that we have here, you can see clearly the brachiocephalic here. You see the subclavian going off its way, common carotid here, and then where it divides into the two other carotids. So the other big one here that you want to be aware of is vertebral, letter D. And these are, this vertebral is one that's going to be running into the brain. It looks like it's in little pieces here, right? But it's not. Why does it look like it's in little pieces? It's going up through the, yeah, remember the transverse foramina of the cervical vertebra? All the cervical vertebra had those holes in them, and the vertebral artery and the vertebral vein, you'll see in a little bit, there's a vertebral vein, but those two run through those holes. And this is one of the main blood supplies to the brain. The other is the internal carotid. And I mentioned this a little bit when we were talking about bones, right? But make a note that these are the two main feeders into the skull. So these are the kind of the biggies. Everything else tend to be branches off of these others. So let's start here. And you can see we've crossed out a whole bunch of these. And you know already a number of these. You already know the brachiocephalic. You should be able to pick out a subclavian easily. The internal thoracic is one we've already studied. So thyrocervical trunk and costocervical trunk. These are the two trunks that you see right here off of the subclavian. Right? Costocervical has got to be going where? Ribs, right? So look for one that has branches that go down to the ribs. You'll pick that out. So there's two trunks there. I haven't given you any of the branches. You should know those two trunks right there. But those are pretty straightforward. Then as you come over here, now we get to the common carotid with its right common carotid, with its external and internal branches here. So these are ones that you should already know for the most part. Shouldn't have a lot of trouble. So we're really looking at new ones up here in and around the head. The external carotid is the more complex of the two. We don't try and mix up all of the branches inside the skull with all of these outside ones. So if you look at the internal carotid there in the picture, you can see that's the one here that's got the least number of branches because it's going deep. Notice also that it's bubbled, isn't it? What are those little bubbles for? right? It's like dotted lines. Sometimes if you want to show the shape of something behind something, you just draw it with dotted lines. That's kind of what they've done here. All of these ones that are bubbled are going behind a bone. Any of the ones that are solid are going over the bone. So this internal carotid you can see, and see this little zigzag up there? See the zigzag here in the picture? If you follow the internal carotid up, that's where it zigzags through the carotid canal. I was talking to you about that a little earlier. And here's where it's popping up right next to the sella turcica. The only branch in this picture that we're going to give it is the ophthalmic branch. That's the one that's running into the orbit. Ocular or ophthalmic should trigger in your mind, should trigger something having to do with the eye or the orbit. Okay? So, internal carotid and external carotid. Make sure you can pick those out. And this would be the carotid canal right here, where it's zigzagging through. All right? Okay, so that ophthalmic branch, the one that's going into the orbit, is the only branch you see in this picture. Anybody know what opening that might go through to get in? What's the main passageway between the brain and the orbit? There's actually two passageways, but one is for the optic nerve. It's called the optic canal, or the optic foramen. You know the other one? No? Yeah, superior orbital fissure, right? Superior orbital fissure is a big slash-like opening. It's not a foramen because it's not like a round hole. It's like a fissure in the ground, like if you have an earthquake and the ground opens up. It's a big slash-like opening. The optic canal is for your optic nerve. All the other utilities for the eye, the nerves that go to the muscles, the blood vessels that feed it, all those other things are going to come through the superior orbital fissure. Now let's feed in the vertebral artery, and you can see that now coming up through the transverse foramina, and you can see it coming up. It comes in through the foramen magnum. So the vertebral artery comes up through the vertebra and then dives in through the foramen magnum. So it's coming in from the cerebellar area and the brainstem area, whereas the internal carotid arteries are entering up by the sella turcica, the pituitary gland, and the hypothalamus. Now, what are the other arteries that we have here? Each one has a very descriptive name. By now, you should have studied the thyroid gland. Anybody know where the thyroid gland is? Yeah, and you can see it's labeled here. You might want to color it in. So obviously, the superior thyroid artery, right, would be the one coming down here to the thyroid gland from above. Okay, lingual. The closest word you might have is in linguistics, right? Which is languages, speaking, right? Anything lingual is the tongue, So look for an artery here that's coming down into the tongue, and you'll find the lingual artery. Then the facial artery, pick out the artery here that's coming up across the face. This one runs between your nose and your cheek, right here. But notice part of it is dotted. I think it's interesting. It begins under your jaw, comes underneath your jaw, and then becomes visible here as it comes out from under your jaw, runs right by the corner of your mouth and up between your nose and your cheek. And so it can give branches into the nose and give branches across the front of your face. The main feeder artery for all the facial structure here is the facial artery. If I asked you to guess which of these arteries was occipital, you should be able to do that, right? Right? Occipital has to be the one coming back here. Maxillary would have to be the one going into the upper reaches of the face here, but from underneath, right? Notice how it's all dotted, so it's deep into the bone, whereas the facial artery here, you want to keep these two separate, is the one right on the surface of the face. What does posterior auricular mean? Behind what? The ear, exactly. Okay? So superficial temporal up over the side and posterior auricular behind the ear. Okay? Each one of these external ones has a very descriptive name. You ought to be able to pick out the part of the external skull that this is associated with. Right? Very, very straightforward. And of course, all of these branches from the external carotid. External carotid, outside of the skull. Internal carotid, inside of the skull. Okay, so how are we doing? We okay? So this one is pretty straightforward. Now remember, when you've learned this, you've learned a lot of the veins already, haven't you? Okay, now let's put this picture side by side with the picture of the brain. Okay, your other hand out. Okay, you can turn the other hand out so that you can see the brain here. And I happen to have a model here that shows the tough part of the brain picture here is that you're looking at a three-dimensional model. You're looking at the inferior surface of the brain, aren't you? Right? So if I show you the inferior surface of the brain like this, the brain stem is coming straight at you, isn't it? Right? You can see the cerebellum sitting here, but the brain stem looks short in the picture because it's coming at you. You're not looking at it from an anterior perspective. But you have to fit that into your thinking right here. Is when I'm looking at this, some landmarks. See the pituitary gland here? Right? Do you know this crisscross here? Okay? Right? The optic chiasm. Okay. Please don't tell me you're leaving the brain to study again before the test. Okay? Don't do that. You already had a brain test quiz. You better be reviewing that every day. Keep it fresh. Don't let it fall. You trying to make twice as much work for yourself the night before the test? No, please tell me no. Okay. So what I want to do here is match these two pictures so we know where we're coming from. Remember, it was the vertebral arteries in the internal carotids that were the ones that were going through openings and into the skull. So you can see here I've colored those two. The internal carotids come in right here next to the hypothalamus. Remember? Pituitary gland, optic chiasm, all of that is hypothalamus. Right? And here's the two vertebrals. They've just entered at the foramen magnum. They were coming up the vertebral column. They've entered the foramen magnum. And here they come, and they do something very, very weird. Very weird. They unite. Arteries always branch and branch and branch. They always make more and more branches of themselves. Very odd for two arteries to come together like you see here. But once you can pick out those in the picture and associate them with over there, you know where we're at. Okay? So, hypothalamus there in the center, where the carotids are coming, and the two vertebrals coming in from below. Now, what's the pattern here? Let's look at it a little bit bigger here then. Okay, so internal carotids are here. Okay? Pituitary gland and optic chiasm right there. The optic nerves cut short. Okay, there's your pituitary gland. Color that in. Right? Optic chiasm. Color that in. Here's your brain stem. Okay? Color in the brain stem. That's where the foramen magnum would be. Right? And here's your two vertebral arteries coming in through the foramen magnum and running up the brain stem. This is basically medulla to about here. As you get to the pons, these two are uniting. And these are going to become what's called the basilar artery. You can see the basilar artery is now going to run up over the pons and over parts of the midbrain. Now, on its way up the brain stem, the basilar artery gives off, now before that, let me back up. Two little arteries come off the vertebrals here. They united into the basilar, but notice a couple little branches unite into the anterior spinal. Well, the brain stem here is connected to the spinal cord, isn't it? So these two little arteries are sending an artery down the anterior side of the spinal cord. Right? Then, back up above, the basilar is going to give off the cerebellar arteries. Right? And several branches are going to be called cerebellar. These are the ones that are coming back here over the cerebellum. And then way, way up here at the very top, they're going to give off the cerebrals. So these lower branches into the cerebellum and one big pair of branches into the cerebrum. Now, what I want you to notice here is that there are three cerebral arteries. Okay? Three cerebral arteries. That's the cerebellum. Those are all coming off the basilar here. But here are your cerebrals. Okay? Three of them. An anterior cerebral that's going to cover your frontal lobes. A middle cerebral. This is going to go off and cover the temporal lobes and up into the parietal lobe, up over the side. And then the posterior cerebral coming over the posterior part of the temporal lobes off toward the occipital lobes. So I've got three cerebral arteries. Notice that the anterior two, anterior and middle, come off of the internal carotid. Posterior cerebral comes off the basilar. So take this step by step, right? Get all of this learned back in the back posterior part here with your vertebrals, basilar, cerebellars, and this anterior spinal. Then come up here and learn your three cerebral arteries. Make sure you can pick out anterior, middle, and posterior. Make sure you know which branches they come from. Don't just memorize the picture. Make sure you know where they're connected, or that you know it so well you could come to it. What if I said, which two arteries in the following list branch from the internal carotid? Could you do that? Could you tell me it's anterior and middle cerebrals? Hopefully. Now, these cerebral arteries form a very interesting pattern. Very interesting pattern. Notice that each cerebral artery is responsible for a certain portion of the brain. The posterior cerebrals are going to cover this posterior part of the cerebrum. Okay? Anterior and middles are going to cover these areas up here. So I've really got separate blood flow to this area from the posterior cerebrals, this area from the two left ones here because they're coming off the left carotid, and these two because they come off the right carotid. So right carotid feeds the yellow area, left carotid feeds the blue area, basilar and posterior cerebrals feed this area. Now this in and of itself is not good. Okay? I don't want each of these three locations to have its own separate blood supply. Partly because if blood vessels in any of these three areas were damaged, portions of your brain would not function right. That becomes problematic because all of the parts of your brain are interconnected, right? The axons, I've got commissural tracts, association tracts, projection tracts. Everything is connected, and every part of your brain relies on other parts to do its job. One part of the brain having a problem could cause a problem throughout. So there is a special circulatory structure right here that tries to equalize blood pressure and blood flow throughout the brain. Rather than having three separate locations, there's some little arteries called communicating arteries, and they unite various parts here. Let me show those to you. Okay? Up here in front, okay, anteriorly, the two anterior cerebrals, I've kind of put these arrows in, but find the actual two blood vessels in the picture, and notice right between them is a anterior communicating artery. This unites the two anterior cerebrals. Now, I don't have two separate locations. I've got them all united into one. What would happen if there was damage or blockage or whatever to the right internal carotid? Would this part of the brain suffer because blood couldn't come up and into this right side? It wouldn't, because where could blood come from now? Yeah, if I had free-flowing blood from the left side, it could flow up here across and fill the arteries on the opposite side. Any problem of circulation on either side can be augmented by blood flow from the other side. Everybody see that? So my anterior communicating is allowing blood to get from one side to the other. You know what it's also doing is equalizing blood pressure. I actually want equal blood flow to all of my brain so it all operates at the same speed. The least little discrepancy in the amount of oxygen on one side would slow its activity and make it not function properly with the rest of my brain. Now I've got an anterior set that's separate from the posterior set. So I've got two final arteries. I've got two posterior communicating arteries. And these are going to connect here from front to back on either side. And now I've got equal blood flow throughout my brain. What I've also got here is a little circle of arteries now, don't I? Right? See how, yeah, I've got blood flowing in from different avenues, but I've got a complete circle of arteries. This area right here has always been called the circle of Willis. You can see it diagrammed in your book. Today we're calling it the cerebral arterial circle. Not in your book, but in your handout. Look at that. See the separate little picture in your handout? Right? That little circle off to the side focuses on the circle of Willis or the cerebral arterial circle. Very, very important cardiovascular structure for every student of anatomy to know. That it provides for emergencies, for problems in circulation, and it also equalizes blood pressure and oxygenation to the entire brain. Okay? Pituitary glands there, hypothalamus in this area. It also is supplying a rich blood supply to the hypothalamus, isn't it? Do you remember what the hypothalamus is responsible for? What? No. Not mechanical stuff. It's autonomic. What? All your chemical stuff. The medulla oblongata is mechanical things like breathing, digestion, heart rate, right? Anything that involves muscle is your medulla. But all your chemical activities, all the levels of certain minerals and ions and things in your bloodstream, hunger and thirst, body temperature, which is a chemical process of burning fuel, all the chemistry. So how does your hypothalamus know the chemistry of your body? By checking the bloodstream, right? By testing the blood, it knows what's happening chemically throughout the human body. And so all blood flow is focused in the brain, is focused first at the hypothalamus, and from there spreads to the rest of the brain. Okay? So any number of things why this circle of Willis is so important, or the cerebral arterial circle. Your internal carotids, right? Anterior cerebrals, anterior communicating, right? Middle cerebrals are there, right? You ought to be able to pick out the basilar, posterior cerebrals, and then those two posterior communicatings, right? Very, very important that you know the blood supply to the brain. Everybody good with this? We're going to bring all sorts of things together here as we're running through this. So these are your two arterial pages. A separate one basically for the external carotid, the external features, and this page for the internal carotids, vertebrals, and all of the internal blood supply. Okay? Let's go to the veins then. Turn your brain picture over. On the other side, you've got all of the vein structures for the head and the neck. And you've got two pictures on one page. So you've got all your internal venous structure in the one picture, your external venous structure in the other picture. So this is going to be like the external carotid page, right? And this is going to relate to that internal structure, although you're going to see it's going to be very, very different. Do you remember the dura mater? Remember the meninges? Remember the dura mater? If you remember, the dura mater, along with the periosteum of the cranial bones, formed itself into little triangular spaces, right? The dura mater actually folds itself down between the two hemispheres, right and left. And it leaves this little triangular space called a dural sinus, right? And the dural sinuses are now what are shown in your handout there. You can see that upper picture shows the internal structures, shows the dural sinuses. Okay, here's a longitudinal fissure, right? Transverse fissure, all of that. So, when you look at this picture here, you see some big sheet-like structures. This is the sheet of dura mater that's down in between the two hemispheres. Here's the sheet of connective tissue that runs in the transverse fissure, right here. And at all the different junctures, you see the formation of the dural sinuses. Right? So just like you see here, right? I'm going to expect to find the dural sinuses in these spots where the dural sinuses form. The connective tissue that runs down in the longitudinal fissure here is called the falx cerebri. This is so that your two hemispheres don't bump into each other. The one down below is the tentorium cerebelli. This is the one that's the roof over the cerebellum. And where these two meet, you have a dural sinus. Where this one comes, where the tentorium comes out here, there's a dural sinus. You know there's one up there along the longitudinal fissure. So this is kind of how you picture where these dural sinuses are. Okay? So here is the superior sagittal sinus. Now, if you remember, a sagittal plane runs this way through you. So it follows the upper part of the longitudinal fissure. This is your superior sagittal sinus. There's also an inferior sagittal sinus. Let's follow, though, before we do the internal ones down here, let's follow from here, running out along this transverse fissure, right here, is a transverse sinus. That one comes all the way to here and then swoops down in an S shape right here. Jugular foramen is here. And the funny little S shape on this is what's going to give it its name, which is going to be the sigmoid sinus. Remember the sigmoid colon? You're going to have a sigmoid sinus here too. All of these sinuses are collecting, as you can see, and leading toward this jugular foramen. You can cross out these two if I haven't already. They should be crossed out. So let's color them in again. Sinuses of the dura mater: superior sagittal sinus, transverse sinus. Here's the inferior sagittal sinus. And that comes to the straight sinus. So you can see, imagine blood flow this way, this way. Imagine that these are taking in cerebrospinal fluid, right? It's all flowing this way, this way, this way. There's one vein here that's colored in the picture, great cerebral vein, but otherwise it's sinuses. And the sort of the final way out from here is going to be that sigmoid sinus. Come on. Okay, follow all the blood flow this way. And then down, sigmoid sinus, and right like that, and out to the jugular foramen. This looks real funny here, but if you look down into a skull, you'll see it clearly. Right? When you look down into a skull, you can actually see the little trough of the transverse sinus here. And then it goes right into this real obvious little, it looks like a water slide, sort of. And it makes just this funny little twisting turn, but it goes right into the jugular foramen. Now, other than that, you have some sinuses. There's the pituitary gland in front. You have some sinuses that are up around the hypothalamus and the pituitary gland. Right, cavernous sinuses on either side, superior ophthalmic veins draining from the eye. Those were the ophthalmic sinuses. I don't come into these petrosals here. And then there's this occipital sinus running down here, and that's inside. It's much smaller than these others. Some blood flow goes down through here, but not a lot. Here's another view. You don't have this one in your book, but I thought it was handy to show a little bit more of how these kind of twist and turn here. And you can see a little bit more of the occipital sinus running down this way. So, all of those dural sinuses are inside the skull and drain all of the cerebrospinal fluid and the blood from around the brain. Now, with this external view, you should probably notice, are these already crossed out on your handout? Should be. No? Okay, cross these out on your handout. Okay. Once we do that, the majority of these are duplicates from the arteries. Let's find some of the main drainage blood vessels here. Here's the vertebrals. If you know the vertebral and the artery, exact same place, right? Vertebral vein here draining from the, really coming from this little occipital sinus. Here you can see a little bit better. The occipital sinus shows better in this picture. And down through the vertebral to the subclavian, right? And of course subclavian into the brachiocephalic. Internal jugular, right, is the one coming from the jugular foramen. So these are the two that are draining the inside of the skull. And all of that, of course, into brachiocephalic. This is the drainage of your skull. Now, the external jugular, notice that it's separate. There's no common jugular, like there was a common carotid. This external jugular here is the one that's going to be draining much of this, although a few of them do go into the internal here. But no matter which one they go to, majority of these are the same. There's an anterior jugular here as well. Pick that out. But now, maxillary, that's a duplicate. Superficial temporal, that's a duplicate. Posterior auricular, we had an artery with that. We have a facial artery, a lingual artery, a superior thyroid artery. Okay? Again, the majority of these are the same. The only ones that are different here, that are very different then, are the pterygoid plexus. Look for the one that looks like a weaving of veins right here, and retromandibular. Can you translate retromandibular? Retro means behind, right, to the back, and mandibular. So I'm going to look for that right behind the mandible. Okay? So I'm going to find retromandibular there. So again, most of these, the name tells you where the blood vessel is. Right? So you've got internal drainage and you've got external drainage. Okay? Internal venous structure and external venous structure. Any questions then about this? We good? All right.